Alright guys, let's look at transition elements. So we know on our periodic table, here's our periodic table, the transition elements are this center group here. And you'll remember when we talked about valence electrons, we say they take at least, they have 2 valence electrons, and that's all we can say. Now, you're going to have to look at this, look at your key, and find on the top right, it says oxidation states on the key. And if you come over here to lithium, you'll find that lithium always takes a +1 charge, right? But let's come over here to iron in our transition elements. If you look at the oxidation states for iron, you will see it says +2 or +3. Remember, that is because it has those d orbital electrons that sometimes can act as valence electrons. So if we have a compound of iron, if it has a 2+ charge, right, and we're combining with nitrate, it would form FeNO3 2, right, because nitrate takes a 1- charge. However, if we were looking at iron with a 3+ charge, it would form FeNO3 3, right, because nitrate still takes that 1- charge. That never changes. So when I name this, if I write iron nitrate, we would have no idea which iron we were talking about. So the way we differentiate, I'll move this, is you see that we indicate the charge with the appropriate Roman numeral following the name. So Fe is iron, okay, and iron has what charge? 2. So we write Roman numeral 2. Then we still go through and write the anion's name, nitrate. Over here, the name of this would be iron. The charge on it would be 3. So we write Roman numeral 3, nitrate. Now, the biggest mistake students make on this is they always want to put the Roman numeral as how many there are. Look at these 2 compounds. If we did that, would we have any way to know which was which? No. So remember, the Roman numeral is the charge. The Roman numeral is the charge, and that tells us which is which. Okay, 3rd page of the packet. You will have a chart similar to the one you just filled in, except every one of those is a transition element, meaning every one needs a Roman numeral. Now, here's something we need to know about transition elements. Some of them, like iron, take multiple charges and they require a Roman numeral. However, others, like zinc, only take 1 charge. Now, zinc is a transition element, but because it only takes 1 charge when we write its name, it does not need Roman numerals because it only takes that 2+ charge. Something else to be aware of, tin and lead, yes, I know they're not technically a transition element. However, you will notice they take multiple charges. So if you see a compound with tin or lead, you need to indicate the charge to show to have the correct name. Okay? So go ahead and give that chart oh, nope, we got to do 2 more. Let's talk about some interesting transition elements that are kind of exceptions. Not exceptions. They are ones you have to watch for because they do something kind of strange. The first one is mercury. Okay? So get out your orange sheet. Find mercury on it. It will be on your orange sheet. You will find there are 2 of them. You will find that there is mercury 2 with a 2+ charge, and you'll look at its name, and its name is mercury 1. Okay? The second, mercury, the 2 plus charge, is called mercury 2. Now, why would this be? Here's the deal. Mercury with a 1 plus charge always exists as a pair. It's diatomic, right? 2 atoms. It will always exist as a pair, and so because each of them is a 1 plus, those total 2 mercuries will give you a 2 plus charge. Now mercury 2 does not do that. So mercury 2 can exist by itself as a 2 plus charge. One of them gives you a 2 plus charge, and we call it mercury 2. So an example of this, so of mercury 1 would be mercury 1 chloride. So what would I do for this? Mercury always exists as a pair with a 2 plus charge, right? So for it to be mercury 1, it has to be like this. So now chloride's charge is 1 minus. How many must there be? I can't separate these. I can't make it HgCl. So this becomes HgCl2. Okay? In comparison, mercury 2 chloride, right, is a single mercury with a 2 plus charge, and it's HgCl. This is still 1 minus HgCl2. So this is mercury 1 chloride. This would be mercury 2 chloride. Yes, you have to actually double this chlorine to make this work. Another one to look at, to pay attention to, is oxygen. Now we know oxygen. Oxygen's a 2 minus charge, right? You can find that. And we call it oxide. Okay? However, look at this one on your orange sheet. Find O2, 2 minus. It's called peroxide. It's one of these again. It's oxygen, which always wants to be as a pair, but the pair of them take a 2 minus charge instead of the one of them taking a 2 minus charge. So an example of this would be magnesium. Let's look at this. Magnesium oxide. So for this one, magnesium, look at your periodic table, has a 2 plus charge. Oxygen has a 2 minus charge. This would be MgO. If we had magnesium peroxide, the Mg, right, still takes the 2 plus charge. That doesn't change. But oxygen takes a 2 minus charge, but there's got to be 2 of them. So that would be MgO2. And so that would be magnesium peroxide. So those are two, this O2 2 minus peroxide and our mercury 1 are 2 diatomic ions that we kind of have to be aware of and look for and know that if we have those, if we have peroxide or we have mercury, they've got to be in pairs to hold those charges. Okay, now go to the 3rd page of your packet, and those are all transition elements. And so I want you to fill in that chart, and again, get on Google Classroom and check to make sure your answers are correct.